So what is this big O all about? Well, let's start with the classic definition on Wikipedia. Big O notation is a mathematical notation that describes the limiting behavior of a function when the argument tends towards a particular value or infinity. Huh. That's the reason why a lot of people find big O scary. But as you will see in this section, the underlying concepts are actually not that hard. We use big O to describe the performance of an algorithm. And this helps us determine if a given algorithm is scalable or not, which basically means, is this algorithm going to scale well as the input grows really large? So just because your code executes quickly on your computer doesn't mean it's going to perform well when you give it a large data set. So that's why we use the big O notation to describe the performance of an algorithm. Now, what does this have to do with data structures? Well, as you will learn in this course, certain operations can be more or less costly depending on what data structure we use. For example, accessing an array element by its index is super fast, but arrays have a fixed length, and if you want to constantly add or remove items from them, they have to get resized. And this will get costly as the size of our input grows very large. So if that's what we need to do, then we have to use another data structure called a linked list. These data structures can grow or shrink very quickly, but accessing a linked list element by its index is slow. So that's why you need to learn about the big O notation first before we can talk about various data structures. Also, big companies like Google, Microsoft, and Amazon always ask you about big O. They want to know if you really understand how scalable an algorithm is. And finally, knowing big O will make you a better developer or software engineer. So over the next few videos, we're going to look at various code snippets and use the big O notation to describe the performance of our algorithms.